C++ doubly linked lists are a very popular data structure. This is because they have so many flexible features that it just makes them very efficient and easy. The first thing that's great about them is that they're bidirectional. That means at any moment we can just spin the other way and reverse direction and go as far as we want in that direction. If this is our linked list, we can easily start here at the head, and the bidirectional traversal just lets us go anywhere we want within here for as long as we want. We can eventually go past the end of it and get to the null pointer, and that tells us that we are past it. So traversal, quite easy. This is a very efficient data structure because we will always maintain a couple of pointers. One, just like the linked list, will always point it to the head, and then we'll always have a pointer to the tail. This makes then an insertion operation either at the head or the tail really quite efficient, just on the order of one, since we already have a pointer right there. And then traversing is also going to be very easy. Just if we had to traverse either way, it could be an order of n operation. And it's simply easier to use these. It's easier to code, easier to understand. So that's why they're so popular. Now, some direct applications for linked lists we will see quite often implemented in browsers. The entire navigation system of going forward and backward with our web pages is built on a doubly linked list. Lets us go back and forth until we finally find something new, and then we branch off into a new thread there. If you've seen the undo feature anywhere, like every editor has, that is nothing more than a doubly linked list. It lets us go back in time, and that has created some kind of a point where we have saved, and if we can branch off from there. Playlists are quite the same. Managing a playlist is just going to be a list that we can go back and forth in. Our operating systems will use linked list for memory management, for keeping track of their memory allocations, their free blocks, etc. And then also operating systems will use a linked list in scheduling, scheduling various processes and tasks that either need to be scheduled or that are currently in process. So linked lists, we'll see them everywhere, and the cornerstone of the linked list is the dual pointer system. Here's a schematic of a linked list, just 4 nodes. They're connected to each other. We have a series of pointers, and with the linked doubly linked list, there are going to be 2 pointers. The singly linked list just had that blue pointer that is going and pointing to the next node. But we're going to add that second pointer, the red one in this case, that's going to always point to the previous node. And then, as you can surmise, the head node will have a pointer to it called head, the tail node, a pointer to it called tail, and then we have a variable node that we can create, pointer that we can create at any time current. If we're going to traverse a list, we just create that and use it and destroy it if we need to. Now the head node won't have a previous, so we set that to the null pointer. Same thing, the tail node down there is not going to have a next pointer, so we set that to the null pointer. And traversing is going to be quite easy. We will just start here at the head, and here we are. We can retrieve then whatever object is contained there in the data area, and we can just traverse the linked list going forward using all of these forward or next pointers. And then finally, if we advance and find ourselves with the null pointer, we know that we have gone to the end of the list. Or similarly, we could also start our journey at the end. Since we have a pointer right to it, let's start at the tail, and then we can just follow all of those previous pointers to find the previous node and traverse that way. And then if we are planning to do some traversal that could be all of that, we combine both of these methods and find that we can use the next pointers to go forward, and then we'll just drop and use the previous pointers to go backward, and so forth until we're done with whatever operation we need. So I hope this schematic just helps kind of frame what a linked list is going to look like schematically and what those operations back and forth will look like.